Thank you for tuning into the replay of our Green Drink September event, where we focused on the alternative building material, Hempcrete. We had Chris Magwood of the Endeavour Centre, Jayeson Hendrysan from Hempcrete Natural Building, and Gabriel Gauthier from ArtCan. Enjoy this replay.
Welcome everybody to Green Drink September. For those of you who don't know me, I am Nick Hebb with SmartNet Alliance. And the Alliance is a group of businesses and organizations who collaborate on projects and initiatives to accelerate the transition to Canada's sustainable economy. So for more information on SNA, you can consult our website, and I'll share that into chat shortly. And be sure to check out our membership pages as well. So we have a ton of different members doing some great work out in the community. And I'll put some links into chat there as well. So tonight we're featuring the revolutionary building material Hempcrete. I hope everyone's excited about this, as I am. It's an amazing material. For those not familiar, our first presenter will do a bit of an intro, so that's great. The material Hempcrete is an ancient technology which has been reintroduced to modern world with remarkable results. So it dates back 2,000 years, and we learned into the trivia that in the 1980s in France, builders evolved this ancient formula, and since then several Canadian companies have been leaders in developing this new building technology, and we're happy to have some of those leaders on the call tonight to do the presentation, so that's great. Hempcrete has now become accepted in many parts of the world as an exceptional building material, with multiple large projects being completed, including single residential housing, row housing, and many commercial buildings. So we'll look forward to hearing more about that. So first up, we've got Chris Magwood from the Endeavour Centre. So Chris is obsessed with helping reverse climate change, which is amazing. And he's doing that by making carbon storing buildings that are also healthy, beautiful, efficient, and inspiring. Since 2011, Chris has been a director and teacher at the Endeavour Centre, a nonprofit sustainable building school in Peterborough, Ontario. So welcome in, Chris. Just a reminder, if folks have questions through his presentation, go ahead and add them into chat, and then I'll sort of quarterback over to him once his presentation's done. So welcome, Chris, to Green Drinks. Thanks so much for being here. Excited to hear your presentation. You can go ahead and share your screen when you're ready. Okay. And we'll get rolling, and we'll get a bit of an intro for everybody who might not know what Hempcrete is. Thanks for joining us.
Sure. Yeah, and thanks for having me. It's really great to be at a Green Drinks event. I have come close to attending some of your in-person ones back when that was happening. Ottawa's sometimes just a little far for a quick trip, but maybe I'll get over there one day. Yeah, so there's three of us presenting tonight, and so I'm going to kind of just queue up an intro to the material, what it is, how it gets used, and then the next two presenters have a lot more practice and practical experience than I do, so they'll kind of take it from there. So you just got introduced, so I don't need to spend any time introducing myself, so I'll kind of get right to it. It was interesting, your question about when was industrial hemp made legal again in Canada. I knew it was 1998 because in 1999 I got a call from a neighbor in the Madoc area who had just grown his first crop and had baled it up and was wondering if I wanted to use his bales in the straw bale building I was doing, which I did, and then we started working on chopping it up and making Hempcrete. So that making of it legal sort of triggered my interest in it and my start with playing around with it. So the material we're talking about, Hempcrete, is made from the core of the hemp plant stalk. So that photo that's there, you can see there's sort of like a thin green layer around the outside, which is the fiber, which is a pretty remarkable material. And one of the main reasons that people grow hemp is for that fiber. But that white sort of foamy looking bit in the core, people call it the hurd or the shiv. That's actually a bit of it's sort of the waste material or the leftover material when the high value either seed or fiber or both have been taken off the plant. And it's that material that we use to make Hempcrete. And the thing that makes it such a great insulation material is that if you hold some pieces of hemp hurd in your hand, they feel very much like styrofoam. They're kind of a nature's version of styrofoam, incredibly light, but still with a bunch of substance. And so they're sort of the base of a really great insulation material. So, one of the things that I really like about working with this material is it's giving a whole bunch of biomass that doesn't have a high commercial value, the potential to also be used when either the seed or the fiber is the main reason for growing the plant. And one thing that Hempcrete is not, and people get fooled because of the word crete in the name, it's not meant to be a replacement for structural concrete. So we're not going to make the frames of skyscrapers out of it. We're not going to build highways out of it. It is a lightweight material and has some structural capacities that we'll talk about, but it's definitely not concrete. And a lot is made of the ability for Hempcrete to store carbon, which is amazing. It's great, but it's not unique to hemp. Essentially, any plant that draws CO2 out of the atmosphere to grow itself, it takes the carbon atoms and builds its structure out of them and releases the oxygen back into the atmosphere. So it's wonderful how much CO2 gets stored by hemp, but also by lots of other plants. So, and I think people have a mistaken notion. I've seen a lot of stuff online where it's sort of made to sound like the building draws carbon out of the atmosphere once it's built, but it's not really doing that. The hemp drew the carbon out of the atmosphere while it was growing, and then we're sort of putting it away in a building. So Hempcrete just has 3 basic ingredients. It has a lime-based binder, and lime is the sort of historical precursor to cement. It's basically burnt limestone, and when it's both burnt and then ground and then rehydrated and then dried out, it turns into a powder that, sort of like cement, when you mix water back in, turns itself back into limestone. So it sort of has a circular process whereby you drive the CO2 out of the rock by heating it up, and it comes back into the material to turn it back into limestone again. So we're using that to coat all the little pieces of hemp. You can kind of see that in the background. There's those little foamy bits of hemp hurd, and they're all coated in lime. So the hemp hurd is the bulk of the material here, and it's sort of, once the fiber has been stripped from the plant, it's kind of chopped up. There's specifications for how we like that hurd to look in order to make a good insulation material, but it basically is just the core of the plant. And then water when we make the mix to set off the curing process of the lime. So we're kind of making a mixture. The lime and water coat the hemp. When we put it into a wall, the lime sort of sticks it all together, provides a fireproof coating, does great things for handling moisture that we'll talk about. And then when the material dries out, it looks like it does on the screen. So the reasons that we like using Hempcrete in our projects at Endeavour, there's quite a few of them, but definitely the leading one for us is its ability to both handle and kind of regulate moisture in the building. So it remains what's called a vapor permeable material, which means that it's capable of absorbing water when the atmosphere or the house is quite humid, and then letting that go when conditions dry out. And it can sort of do that repeatedly over and over and over with a huge amount of storage capacity. A cubic foot of Hempcrete has the ability to store about 8 pounds of water vapor without that water turning into water droplets. It sort of keeps it in a sort of separated, suspended form, and then it's able to dry out. And then the lime coating on the material is it's very basic, and so it's naturally antifungal and antimicrobial. So when these walls, or if these walls get wet, they're extremely tolerant of moisture loads and moisture cycling, whether that's from getting wet from rain, getting wet from plumbing leaks in the building, or just the vapor cycle that homes go through. So this is one of the things that makes it so unique. Lots of other materials can make a permeable wall, but it's the sort of the large capacity for this to do it, and the way that the lime kind of allows it to happen in a very safe way, where you're highly unlikely to get any kind of mold growth. It's also incredibly fire resistant. So again, unlike other untreated agricultural materials like straw or rice hulls or things like that, the lime coating, it's essentially, every piece of hemp is coated in a little bit of stone, and so it doesn't combust. It passes really stringent fire tests. Here in Canada, it's passed a 68-minute fire test, and which is well within the sort of code requirements for residential buildings. And in fact, some of the European tests sort of point to it being able to be used even as a fire stop wall in commercial buildings, although it hasn't been tested to that level yet in Canada, to my knowledge. It's an insulation material, so it has some thermal properties that are desirable. However, it doesn't have the greatest R value per inch. The typical wall mix that we use and that most people use comes in somewhere around R2 per inch. That's not terrible, but it's not great. It's not one of the best insulators, but it's also, there's a lot of issues with how R value is tested, and it doesn't always reflect the way that a material will actually perform in situ. And when we look at actual in situ tests, we see that it's much more on par with other materials, which would be rated at sort of R3 to 4 per inch. But in general, what this means is that right now, for code purposes, the walls become a little bit wider. Code here in this part of Ontario is R24 for most walls, and so you'd be looking at making a 12-inch wide wall of hempcrete to meet code. Let's go forward. So the thermal properties are much closer to sort of other mineral-based insulations like aerated concrete, expanded clay and foam glass, which are all sort of between R1 and R2.5 per inch, versus untreated plant insulations like hemp wool, straw bale, and sheep's wool, which are sort of 2.5 to 4 per inch. So it doesn't make it a bad choice. It's one of the considerations that we have to take, that we make the wall a little bit thicker than with some other insulation materials. It has a slight bit of compressive strength in terms of its structure. Depending on the mix, you can vary the strength by varying the amount of lime binder that goes around the hemp. So the more lime binder you add, the stronger it gets, but the more lime binder you add, the less insulation the material offers. So, we're typically looking for lighter mixes in the cases where we're solely relying on this for insulation, but we have made mixes with higher strengths to do things like insulating under floor slabs or other places where there's going to be some weight resting on the hempcrete. In general, though, it is, for an insulation material, quite structural. And so when we work with engineers, they see its value in sort of supporting and stiffening framing for walls. So that sometimes we can extend the spacing between studs, or go with slightly taller walls than code would not really allow. And then one thing to remember structurally is that the material is quite friable, which means it's got a bunch of structure until it crumbles. And then when it crumbles, it's just crumbly. So it sort of has a failure point that's quite decisive. And so it's never relied on for structure in any sort of seismic conditions, because when you shake it around, it crumbles. And that's pretty normal. We don't typically rely on insulation for structure in that way. In terms of the environmental performance, hemp production is pretty low impact in that it typically uses fewer herbicides and pesticides than lots of traditional crops. In fact, in some cases, none at all. And the herd production that we're using for this material, like I mentioned earlier, is secondary to cedar fiber production. So whatever impacts there are, you're now sort of sharing between multiple uses. There aren't really any byproducts or industrial waste from the material. I mentioned the carbon storage. We'll look at some figures for that in a minute. And because it's typically used as a site mixed infill type insulation, there's really no waste on site. It's not like we're getting sheets of it and cutting it up and having to throw out the bits that don't fit. It's mixed loose, we put it in place, and so we use exactly as much as we need. And it has great properties for indoor air quality in buildings. That lime binder and the moisture storage capacity make for really great clean air, and there's no sort of chemicals or anything off-gassing from it. So a lot of really great environmental properties to using it. Some things to consider, though, in terms of its environmental properties. The lime production is quite energy and carbon intensive. You have to quarry limestone, heat it up to a pretty high temperature. You can sort of see the chemical formula for lime, and I mean, it is something that is cyclical. You could remake lime plaster or lime binder again out of existing lime. We drive the CO2 out of the rock, and then a lot of the CO2 comes back when the material carbonates. That's not 100%, so we do leave some carbon in the atmosphere from this process. So when we calculate the carbon footprint, we're taking that into account, that a bunch of CO2 from both the fuel to burn the rock and from the rock itself is in the atmosphere, and only a portion, typically around 50 to 60% of it ends up back in the mix over the first couple of years. And then other environmental factors, when people start growing hemp on a large scale, certainly the farmers that I've talked to here in Ontario are using fairly high quantities of fertilizer, quite often in the neighborhood of what it takes to grow corn. And we also want to make sure that we're not encouraging vast monocrop agriculture with hemp or any other plant. So as this grows in size, the sort of interest in hemp in all its uses, and in this case Hempcrete, we want to make sure that the farming practices are as sustainable as possible. Whoop, there's a little graph that did not translate to PowerPoint, but this is looking at the carbon footprint for about 1,000 square feet of wall. It's actually 100 square meters of wall at R24. And Hempcrete is sort of offering net storage of about 2.6 tons for that much material, for that much wall area. Sort of on par with straw bale at 2.8 tons, wood fiber board. Whoops. Sorry, this slide's there. But most insulation materials are actually responsible for emissions. And if you could see down to the bottom there, things like spray foam are actually about 5 tons of net emissions rather than the 2.5 tons of net storage for this same level of performance. So a pretty remarkable difference in carbon footprint, and is part of the reason that we're able to make buildings that are on whole net carbon storing rather than having any emissions associated with their materials. I'm gonna think I'll come back to this one. This is what the kind of alternative solutions look like when we're presenting a Hempcrete building to a building official. I think I'll loop back around to that towards the end of the presentation. So places that it gets used in the building, you already know some of this from the trivia at the beginning. So we use it as a ceiling or roof insulation, largely as wall insulation. That's definitely its sort of leading use. We have used it under slabs for insulation in that place. A version of Hempcrete with more lime and less hemp gets used as the plaster on the walls. And we also do a lot of work with it, it's both decorative but also thermal by using it around windows as integral sort of window trim and insulation and sills kind of all in one. We really like it for that. And we make a more dense version for things like bench tops, countertops, things like that. So lots of places that it can end up, but by and large, wall insulation is its main use. We're also seeing it as a really great material in renovations. So when we're looking to insulate an old building, such as the one in this photo, quite often these buildings, in this case, it's a concrete block building, so it had no framing. Or when we're looking at older frame wall buildings, the sizing and the spacing doesn't really suit conventional insulation bats that come in very particular sizes. And the beauty of Hempcrete is that we can add whatever thickness in whatever width to whatever R value makes sense for the building. So it's a really flexible way to be able to go in and retrofit a building and get a really great fit for the insulation, get the insulation to be quite airtight, and be able to do that while the existing walls and cladding are still in place. Some things that we have been playing with quite a bit recently is making Hempcrete, but without the hemp part. We've been doing that because right now the sources for hemp, particularly in Ontario, they're highly variable, and farms that process herd seem to come and go on about an annual basis. So we've been looking to some other materials that share a lot of similar properties to hemp herd, including sunflower stalks, sunchokes or Jerusalem artichoke stalks, miscanthus, cup plant. There's a whole bunch of things. They all work in the exact same way. We get the same kind of mix with the same kind of density. I went to visit a builder in Mexico who's doing a similar thing with coconut shell. So really, this is an approach that it works really well with hemp, and that's kind of where the notion started, but we're definitely not limited to hemp. And I think the fact that so much ag residue is suitable for doing this, it makes it very possible to sort of find whatever plant source is local and be using that. Other things that are happening, people are starting to figure out how to spray Hempcrete in. One of the disadvantages of working with Hempcrete is that it's wet mixed, and then we're typically putting formwork on the walls and packing it into the forms. And that's obviously a slightly slower and more cumbersome way to put in insulation than with a lot of other systems. And so spraying allows for there to not be formwork on two sides and for the work to go a whole bunch faster. Also, people are starting to make Hempcrete in forms where it's not being cast on site and in place. It's being precast, and that's everything from blocks to sheets to full wall panels and blocks that have a sort of structural frame built right into them. So these are all different systems, and I think my sense is that as Hempcrete becomes more widely used, it will be in these forms rather than as the sort of DIY mix it up yourself and put it into forms yourself. There's a whole lot of advantages that come from having it be precast. one of which is you don't have to source the materials, and the second of which is you don't have to sort of accommodate the drying time for the material in your construction cycle. When somebody else is precasting it for you, they're sending it to you dry, so you can, work with it and cover it up and move on right away. A bunch of other materials that are made from different parts of the hemp plant include a great hemp wool or hemp bat insulation, currently being made in Canada. There's a small production facility in Quebec where it's being made. We've started using that material a lot because it's almost the same price as rock wool, but has all kinds of much more desirable properties. And so that's been a great option. There's a production facility starting up in the US as well. Hempwood flooring is really starting to take off. They have a factory in Tennessee, and their sort of production is now ramping up. And it's a sort of a board product. It's the whole hemp plant pressed together with a really interesting sort of bio-based adhesive, and typically used as flooring, but the wood can be used, in replacement of wood in lots of ways. Hemp panels. These are 4x8 sheets of pressed hemp hurd with a little bit of fiber in them, similar to like an MDF board, but made from hemp. And we've been finding that putting a surface treatment on that, like just a clear coat, people really like it as a finish. I'm not sure that's what it was intended for, but also people using it for cabinetry and anywhere else that you'd use a particle board. And a really interesting one that's now in production in the UK, and we're hoping to use that on an upcoming project, which is a corrugated siding where the hemp fiber is sort of woven, and then a hemp-based resin is cast around it. And so it's a panel product that you can use as the exterior cladding. And I'm sure that there will be other ways that people figure out how to put hemp into buildings, but it's not just Hempcrete. There's lots of interesting stuff going on. Just a quick look at some of the different Hempcrete buildings that are out there. A few of these are ours at the Endeavour Center. A few others are the other co-presenters here, and you'll probably see more finished buildings. But one of the things that I really like about it is it doesn't have a particular aesthetic to it. You can really make any kind of building. You can make it look any way. Lots of these examples are plastered, but you can also clad it in any kind of cladding. So it doesn't really kind of dictate what the building's going to look like. And this is our most recent Hempcrete project. It's a classroom at Trent University, their new forensic crime scene classroom. And for that, we did use the Just Biofiber Hempcrete blocks. You can sort of see up in the top left. So it's a Hempcrete block cast around a composite frame. And then we also use the hemp bat insulation inboard of that to achieve a net zero building. And it was really, exciting to be able to bring what are considered, fairly alternative materials to a more institutional building, and one that kind of doesn't really look necessarily like a sort of alternative or hemp-based building. And the university's been really happy with both the sort of the cost and the performance of the building to date. And that one's being certified as a zero carbon building through the International Living Future Institute. And this is just a couple of shots. We are quite a bit behind the Europeans and the British in terms of the use of Hempcrete. So this is, there are lots of projects like this going up where precast Hempcrete panels are being used, in this case with a glue laminated timber frame, to make very large buildings. This is a big Marks and Spencer department store in the UK. But the sort of the scale at which this material is being used in Europe is far past where we are now, and hopefully as more people learn about it and as the sort of building industry gets a little more adventurous and a little more climate friendly, more things like this will start to happen here. And if you're looking for resources to kind of dive in and learn more about this, I have a book called Essential Hempcrete Construction, and the Hempcrete book from Alex Sparrow in the UK is really great. And Steve Allen's book has been around for a while, but sort of really kickstarted a lot of people's journeys with hemp. So those are all great resources. And at Endeavor, we have a lot of hands-on and now an online Hempcrete course as well. So you can check that out on our website. And I think that brings me to the end of my intro bit.
Great. Well, thanks so much, Chris. Some fabulous work you're doing. I love to see those buildings. Some gorgeous buildings there. We do have a few questions come through chat, and I did share the Endeavor Center link for people who are interested. So that's great. Daniel's wondering, does the material expand as it absorbs moisture?
No, it stays incredibly stable, which is one of its great properties in terms of moisture capability. We did some testing at Queen's University with that, like really heavy moisture cycling, where we would load it up to sort of 100% humidity and dry it out, and we didn't see any measurable change in size or any degradation in the material.
And that's great. So Michael was expanding on that. How does the use of dehumidifiers or air conditioning affect the integrity, durability of hempcrete if moisture is artificially or continually sucked out, mostly from the inside?
Well, it doesn't really. It happens incredibly slowly. And what sort of the sort of in situ testing has found is that it actually works like a sort of moisture battery. So, at moisture levels, both inside the building and outside the building tend to, cycle fairly frequently from day to night, from season to season. And so, when the conditions are humid, the material is taking it up. Like I said, it can do it at the rate of up to 8 pounds per cubic foot. So that's more moisture than any sort of natural conditions would ever present. And so the transfer is much slower than you'd think. It's not like, oh, it's dry out, the house is really dry, like everything got sucked out. It's, there will be a gradual movement from in to out if it's drier outside than in, and a very gradual movement in the other direction when the conditions are reversed. So what we find is that people's ERVs and HRVs have to run a lot less, because the humidity in a building, a lot of the reasons we ventilate buildings is because we build them in such a way that moisture has nowhere to go. Every single surface is impermeable. We use plastic vapor barriers. And so when the air is moist in a building, you have to suck it out and get it outside, because otherwise it will, condense and start to cause mold issues. And that just doesn't happen in a building like this, which can, take that moisture on and let it go without it getting to really high levels of concentration in the building.
That's fabulous. And Santa was just wondering about soundproofing. Is it a material that provides a decent amount of soundproofing? Or?
Yeah, it's actually really great for that. I should add that to my list. But one of the things that people who step into a hempcrete building for the first time, that's actually one of the first things that people will comment on, is like, oh, it sounds really quiet in here. And so it does have a really great sound dampening quality.
Oh, that's great. Yeah, good for the neighbors. Lynn was wondering, does the release of CO2 in creating the lime negate the storage of carbon in the hempcrete?
No, so that figure I gave was a net figure. So, the life cycle assessment takes into account, all the inputs and emissions. So that's, after you take all the lime stuff into account, there's still more carbon stored in the material than was emitted in making it.
That's great. And Christina's wondering, do we have a Canadian spray system available, or something that you recommend?
To the best of my knowledge, and Jason and Gabriel probably know more about this, I don't know of anybody who's spraying here. We have some really interesting people doing precast work, but I don't know of anybody doing spray here.
Okay, we'll carry that forward. Judith is wondering, could you please repeat the comparison of hempwood bats to wool?
To rock wool.
I believe so. Yeah.
Yeah. Yeah. So they have the same R value per inch, so just shy of 4 per inch. The same shape, the same form, but the hemp wool bats are they're about 5% right now more expensive than rock wool. So for an alternative material, that's actually pretty close. And it's still being made on a fairly small production line. So I feel like it's one of those materials that will actually end up being cheaper than the kind of current choices, just because the raw material, when you make rock wool or fiberglass, you have to heat up glass or rock till the point where it melts, and then you're sort of making melted glass candy floss. So there's a huge energy input there that doesn't need to go into the hemp bat. So once there's more scale in the production, I think we'll find the cost is actually less than the conventional options.
That's great. And Michael, we may want to carry this over into chat, but Michael was just wondering if you can recommend any contractors in the Ottawa area that are familiar with Hempcrete. So don't know if that's something you want to throw into chat there, but
yeah, there aren't a lot. There are a couple of people in the Perth area who've done a bunch of work and are quite knowledgeable. I don't know of anybody sort of right in the sort of like Metro Ottawa area who are working with it.
Not yet. Maybe after tonight, we'll get some people motivated, right?
Yeah.
So fabulous presentation, Chris. Hope you can stick around. We'll have some time for some follow-up questions as well. Really appreciate the work you're doing out there at the Endeavour Center, and great to bring your knowledge out. So hang tight. If folks have a few more follow-up questions for Chris, we'll have some time at the end. Thanks again, Chris.
Okay. Yeah.
So next up, we have Gabriel Gauthier, and he is a pioneer of hemp construction in North America. He has more than 20 years of experience as a professional artisan and specialized contractor. His company, ArtCan, has been in operation since 2003, where he supported more than 100 self-construction or renovation projects in hemp and lime, mainly in Quebec and Ontario. In 2015, he founded the company Gabriel Construction with the aim of professionalizing its services for commercial, institutional, and residential projects. So welcome in, Gabriel, to share your screen. Thanks for joining us, and tell us a little bit about your experience with Hempcrete.
Hi, everybody. Yeah, you heard me well. Okay, yeah.
Yeah, you're coming in well, yeah. Yeah, we'll give you a couple seconds to share your screen there.
Okay, share. The button is there.
Yeah, there we go. Thanks so much for joining us, Gabriel.
Okay, so yeah, thank you, Chris, for this nice introduction with a lot of details about the Hempcrete and all that. So I will present some of my project I did since the last 20 years, mostly in Quebec and Ontario, mostly for renovation and new home too. And we do a lot of hemp line finishing too. And also we was working, we tried to, we did some project with spraying, and now our main product is a precast hemp home that we build. So yeah, so the hemp construction is for I will skip quickly but I just want to add a point about the earth. Why the earth is so great for the Hempcrete is then it's really rich in silicate, and it's really mineral. So I found then it's one of the best particle shiv or vegetal particle to do a Hempcrete like that with a masonry, an organic masonry. So this is one of the point for the. Then it's the best. It's why the Hempcrete is that much high quality. So the basic work with then we do a lot of work was with a standard planetary mixer. After that, and after, it's really simple, and if it's a handicraftsman way, but it really efficient. We put that in the bucket, square bucket. We put that in the in the form. After we have some things to take care about the frame. The frame could be really simple with 2x4, but there is in the window spot where we take off a piece of wood to make it easy to put the hempcrete in. No, it's not a good button. Sorry. And after that, just packed well. Take more care about the edge around the square, the 2x4, and the edge, the side of the form. And after, we could unscrew that, and you have a monolithic Hempcrete wall done quickly. So this is one of first project, and one of other things that we take care. I love to work with fork to mix to pack the hemp and the layer of hemp together in the mix, layer by layer. It's get a better fission, a better fission of the layer together. Also, we could work with many kind of frame. There is a timber frame designed really for the hemp and for the window, and it was make a great mix together. And this wall never had another finishing after. They found it really nice like that, so I call it brut de chanvre, or raw hemp wall, and it could stay like that for as a finishing. So also outside we could do a wood siding with a airspace to aerate the exterior, and many kind of project could be. Also, we could. There is a project where we have the hemp floor. The hemp wall is continue in the roofing, so it gives you a complete Hempcrete shell for this house. We have also, we take care about often if we want to do a lime plaster outside, we have to take care about often we need a design is good for that. It's to have good big overhang around the house. This is some years later with the finishing, and I have a lot of slides, so some are going faster. This is a little addition, but what is interesting is there we have a hemp floor with the then after that floor we put oh, there is a precast hemp. After this we do this is our precast wall. Now we're building that in the shop, and we could keep it dry faster, and when we bring that on the site, it's take 1 day, and the house is done with the system of roofing. So there's a precast wall. Okay, I come back with my my M floor. So M floor have to be done on site, and it take time to dry. But after that, it's really smooth for barn, for structure. We feel really. I found the concrete really hard to be to walk on and work on the concrete floor all the day. So with the Hempcrete floor, it's really more smooth. And this hemp floor was just finished with slate and without eating, and it's really comfortable. We are without shoes in the winter. It's hot enough. There's another project in Montreal. We just restore a lot of buildings are made with brick, structural brick, 2 layers, and we could have a good answer for that with the hemp lime coating. It's more like it's the hemp lime that we use for finishing, but with 2 or 3 layer of that, we get a good amelioration of the. We get an efficiency of the thermal and regulation of humidity and air leaks too, and we get for really easily a good restoration of a whole building like that. I have a lot of slides. This is another example with a home. Then we restore from I'll just say that piece of wood on piece of wood, whole home of the campaign, and we just bring that to the piece of wood, take care about leak here, and with lime coating we do the finishing of this room really easily, and it's a nice finishing. We have some hemp in it, but with white sand too. Okay, some other project. This is another project. Then we build in the 7 month in 2011. It's a lot. We have a lot of lime coating in this room, and often we work to get the window some design with round trim around the window. This is another example for an addition on a wood, I would say, log home. You see, then we have here a post because the log home gonna move, but the Hempcrete is really stable. So we have to do this transition with by this way, and it's worked well. This is another example of lime coating and a lot of overhang all around the house. And another example is there we done some wood. It was a specialized project. We don't do it on many projects, but and inside is a wall for incinerization with and when we do the incinerization Hempcrete for soundproof, we put more density and we put more sand in that. But we need it's a lot of detail to get a good soundproof wall. Yeah. Other way of artistic sculpturing around the window and wood. This is we did some project with the Provencal ceiling. So Provencal ceiling is what you see here at the top, at the ceiling. It's not just a board of wood. It's a 6x6 of wood on the diagonal of a 6x6 of wood to have a part. So on the top of that is 6 inches floor, and I walk on the top of this ceiling. So it's replaced the board, and it's a system of structural insulate soundproof floor and ceiling in the same time. We did some project with the bottle where the Hempcrete was a nice solution to do the finish, the sculptural finish of around all this bottle. And after that, we just put the lime coating. Often we need, for example, kind of design when we need for a lime coating outside is some stone, and we fix on the bottom of the wall. There's another project near Chelsea. Back there, it's a little project. I want to show you. Often the client, I have some proposals, many ways is possible to build a hemp home, and on this for this client, he want to build it with a hemp from the field. So it was the slow food building for Vallée de la Batiscan in a area of between Trois-Rivières and Quebec, and we did that with clay and hemp from the field. But as was with all the fiber we have in it, it was more labor intensive, and also Hempcrete is at the beginning labor intensive too. So we mix the technique here to do the Hempcrete with the clay for the part here, and in the front we just insulate that with the hemp stabilized with lime, and in the box, and after we do the lime coating both side of the lime coating on you see on the little stick like that. This is a really simple way to do division or kind of sculpturing things, and so this little stick with the lime coating, you made a lot of possibility for finish a home or a shelter or whatever. And there we see this mix is the binder was only clay. So it's oh, sorry, go faster. Another house in then we built in 2017 with a lot of it's with a lot of how do you say, benevolent people that want to learn on this house. So we share our knowledge, which are around 75 people on 8 weeks on this hemp home. This hemp home have a lot of Hempcrete all over. Also for the hemp ceiling with the same technical than the I use for Provencal ceiling, but we just adapted for this structure. It's not really, it's not a 6x6 on this way. It's we don't have a we figure a system and it was working, but this was a bit labor intensive. But for some project, it's interesting. This is another. I coach Benoit Chartrand in the area of Prescott Russell, and he wants to build his business. His business is now is a Tech builder, and it was his first home he want to build, and he want to build that similar to another one. To other home, so and he get it. So, and this is hemp home with a standard lime coating and some decoration for style. Another project here in Val David with a nice design. This have particularly a nice big M floor for the floor. many possibility to sculptural too. Often we use the Hempcrete to get the basement more dry and finish. And this is an example of old work in Montreal. Another project we did institutional some years ago in 2016 and 2017. It was the Domaine Trinity in the Saint-Jean-sur-Richelieu. It was made with spray. We sprayed the Hempcrete on all the surface of a church and the presbytery, and it's now an area for cultural happening and all that. And I'm really happy that they choose the hemp lime coating for finishing, because the acoustic of this big this area is it's really special. It's not don't have the same echo with the Hempcrete finishing on the wall. So this is the project of Trinity. And some people want to know if it's burned. So this is an example of a wall. And the roof will have a big 16 BC4 beam on the top. It was all burned. I think the window was in and it was burned. And after the winter, when they at the destruction of all that, they take the Hempcrete wall and the stone, stick with that, go with it. And it was but this was made with hemp lime and plaster. So I did a lot of project with this kind of binder. It's based on lime coating. It's based a lime base binder, but it's more stronger with the plaster, but it's not easy to use. Yeah. And often the people want to know if it's lively. So why the Hempcrete is that much comfortable and amazing is that it's because it's really lively. It's a lively material, and it's talk to a cell. And this is an example with of the material reconstitute. It's about the vibration of the wood. If you do this test with white sugar or rock wool, you have almost nothing. So this is not the same vibration. So this the way is that I have to show you. If you have some question, I could.
Yeah, thanks so much, Gabriel. What a fabulous project. Some gorgeous homes there. Wow, inspirational and nice to see some stuff in Chelsea and Val David, close to Ottawa here. So that's great. No, absolutely some fabulous ones. There were a few questions, but I think Chris was able to jump on a couple of them. So I think we'll, in the interest of time, we'll kind of roll over to Jayeson for now. But if you don't mind sitting tight, we'll see if there's any follow-up questions after Jason's presentation. But absolutely some amazing buildings and homes, and what an inspiration for folks that maybe want to build their own. So credit to you for doing that and giving everyone some inspiration. So thanks again for joining us, and we'll have you at the end for a bit of a panel discussion and any follow-ups there. So once again, really appreciate you joining us, and some amazing work you're doing there.
Thanks a lot. See you later.
Great. So next up, our last presenter is Jayeson Hendrysan, and I got to give the hats off to Jayeson, because a few months back when I decided to try to put this together, Jayeson was the sort of first contact that I reached out to, and he was able to connect me to Gabriel and Chris. So heads off to Jason for really being able to put this whole evening together. So he is a true pioneer in the green building industry. Living on the Pacific Northwest coast of Canada, he has been engaged in the alternative building industry for over 12 years. In the year 2000, he helped to build the first known Hempcrete home in North America. And shortly after, he launched his company, Hempcrete Natural Building Limited, and we'll share a link there. They are one of the only accredited hempcrete building companies in Canada, and they provide sustainably designed homes for home purchasers, developers, and communities who want to reduce their carbon footprint. They have been awarded research grants with the Canadian government and are working with Natural Resource Council, Research Council in Ottawa to test and standardize the material for broad Canadian use. So welcome everybody, Jayeson Hendrysan, to our Green Drinks stage, and he can share his screen and get rolling on his presentation.
Hi, thanks a lot, Nick. I'm on the West Coast on an island, so I actually have to, if I am starting to get bad internet connection, I might have to mute my video or stop my video. So just wave at me or let me know, but we'll give that a try.
Yeah, you're coming in pretty good right now, so
Great.
we'll share your screen. We'll see how everything goes, but fingers crossed we're good Wi-Fi.
Yeah. We're supposed to have the highest rate of speed available on our island, but sometimes I wonder. Hey, well, thanks for doing this, and thanks, Chris and Gabriel, for starting this out. I just want to say one thing when I start here is that Gabriel finished with his slide of the energy of the Hempcrete, and I've seen this for dozens, if not hundreds of times when we build a house or we build a wall and we take the forms off, and everybody around that's never seen a raw, wet Hempcrete wall before, they always want to touch it and feel it. And in our work with the NRC in Ottawa, the head scientist there actually said, when I mentioned this to him, he actually said, well, you know what, that's because the resonance frequency of the Hempcrete on the line actually resonates at the same level as us. And so he's the head scientist there, and he's talking resonance frequency. And our engineer was like, what do you mean? You know, that's kind of out there. And he's going, no, everything vibrates. So I think, you know, the whole idea of green building and natural building is really important. But we also think that it can affect us in ways that we can't, you know, touch or we feel it. We know it and we feel it. But and it creates a very healthy home for a lot of things. So 20 years ago, there we go. 20 years ago, there's my lovely wife on the right, and myself. We, through just total circumstance and we were working with a PhD in concrete, we built our first Hempcrete house. And how it came about was he had his actual PhD in concrete. He was an engineer, and he said to us, we were trying to make some kind of biocomposite lightweight concrete, and we were using straw. And he said, well, don't use straw because it rots. And he was giving us all these things that produces bacteria within 4 hours of being wet. And I was so determined that I knew we could do something different and do something more environmentally friendly than concrete. And at one point he got exasperated. He said, well, if you're going to use any kind of biological material in your concrete, use hemp because it doesn't rot. And I said, well, it's illegal. And he said, no, it's been legal in Canada for 6 years. So that kind of got us going, one thing after another. And it's a really hands-on here. Here I was at the College of the Rockies in Preston, BC, doing a little sample wall for them. And my wife there is using natural pigments. So in all of our plasters, we can use natural pigments to either paint the walls or put the color into the wall, or else put it on top of the plaster. So that was her very first Hempcrete wall that she colored. And there's our first house that we did. And so we started, really, that house was finished in 2002. And we've been building, consulting, doing design and architecture, cost analysis, hemp specific, and general contracting. So we've kind of started from the ground up, and that's quite different. We've bruised our knuckles, and you know, we've gone through it all, and we've helped a lot of people. We've consulted in projects in Costa Rica. We're consulting on a project in Hawaii right now. So it's really exciting to be a part of this movement. On the left there, you see was the first commercial, we've done 3 of them now, but this is the first commercially accepted hempcrete house on a metal frame. So we actually picked it up, we built it in a factory, we picked up the whole house and moved it to the location and set it down, and then finished it on site. So that was the last 3 years, and we just got finished that place in May of this year. So we've done prefab modular products, like everybody, like Gabriel and Chris. You know, we're always trying to find, hempcrete is a very dirty, messy way to build. So we're always looking for blocks or panels or spraying or something or other. But the other thing is, if you do it correctly, a 2,000 square foot house can be poured in 10 days. So it doesn't have to take a long time. So we've kind of figured out the best way to do it as a do-it-yourself, and then we're now moving into factory and pre-modular stuff. So this was the original plan for the house. It was a 650 square foot house, and it's made to expand up to an extra 1,000 square feet. So as the family grows or circumstances change, that we want to make, if these buildings are going to last hundreds of years, they have to be adaptable and changeable with the family. So we're starting to try to make smaller houses that are more affordable and manageable for people as well, but they also have to be expandable and versatile in their performance. So Chris covered a lot of these points. I'll just mention a few of them. So in this picture on the left, you see is magnesium board ceiling. We've totally dropped drywall. And then the hempcrete walls, it's got hemp plaster on the ceiling, and then the walls are all hempcrete as well. So it's got the strength and durability. The energy efficiency of the hempcrete is interesting, and what's come out of Europe recently is something called thermal inertia, and that could explain, for a lot of us who live in hempcrete houses, we find them just so comfortable compared to what the laboratory test results say about R value or things like that. And thermal inertia explains a lot. And that's R value would be the resistance to heat transfer through an object. And thermal inertia is the resistance to heat changing temperature. So, and some of the results from Europe are showing that hempcrete has 8 times the thermal inertia of rock wool insulation. So even though the R value is quite a bit lower, once the hempcrete gets to a temperature, we find it doesn't like to change from that temperature. So that can be very good. Obviously, it's got fire and pest and mold resistance. Chris covered a lot of this. You know, one of the reasons, the second last reason there that I'd like to point out is that it's really important that we start to look at what we're doing to the planet and our building practices, and even a small step. And that's been our model right from the start. You know, we're still using some caulking that's probably not the greenest caulking that we have to, but you know, we're made to do it by the building code. We're going to go ahead and do it, and we're going to look for other solutions. And every little step, if 10 million people make a small step, we could help tip the scales. So that's kind of what our philosophy has been, you know, and we keep improving with every house we build. And even just this last one, in British Columbia, we have a 10-year warranty on a house, and I'm proudly part of the system. I'm being recorded here, I know. And but at the same time, I want my fridge to last 10 years, not my house. So, you know, it's kind of a dual thing. We're part of this system that wants a 10-year warranty on your home, and yet we want to be building that's going to last hundreds of years. So we have to walk both. If we want to be commercial and reach a lot of people, we have to kind of walk both paths at the same time. So on the left is our first. We helped a wonderful guy in Alberta who's helping people build hempcrete homes now. That was his first on a metal skid. You can see the metal skid here. And it was a very small 300 square foot house that could be picked up and moved. And on the far right, again, is the first house in the world that we know of that was built to the standards of warranty and insurance and new home warranty and all that. And the house in the middle was actually a Mandela house. They're a company in British Columbia that does modular roundhouses. So we worked with them a number of years ago and put up their modular roundhouse with that company. So we've been playing around with it. On the left here is a duplex we developed, and we've got actually a number of people very interested in the duplex idea. And so that's been gone through. And I don't know where this picture came from the right, but it's just a bit of a different look of the possibilities of the design. And Chris and Gabriel showed you some of the design as well. So we really focus on natural materials in all of our houses, timber, tile, and natural plasters, glass, metal, wood, stone tile, as much as possible. The tile works really great on the Hempcrete walls. And so we just really want to focus on all of these aspects to create beautiful and functional houses. There's the roundhouse. And again, you can see some of the arches up in the top of the picture. Gabriel had some wonderful arches that can be done. So you can get really crazy and do some great designs with the Hempcrete. Here was the little house we just finished. So again, with all hemp plaster and magnesium board ceilings. Chris touched on this. We worked with an energy advisor on these on some of these numbers, but we can achieve a minimum of 45% energy improvement over using different technologies with the Hempcrete house, and that'll even go up as in British Columbia, our electrical prices are going to be rising in the next few years. So, and then this is again covered by Chris, but you can see the Hempcrete carbon footprint, embodied carbon, and they're all heading to the left, with only the dense packed cellulose going in the same direction and everything else heading off in the wrong direction in terms of environmental damage ultimately. So one of our key things is we want carbon neutral housing. And again, as Chris pointed out, depending, you can play with your numbers all sorts of ways. But we really want to take as many steps as we can towards that and conserve our construction resources, reducing the waste on the construction site. And then it's not just about the Hempcrete house though, it's how the Hempcrete house interacts with the mechanical, electrical, and water systems. So we can create a very complex technological way of doing an old technology and using mechanical engineers to make it a smarter way to build in a complex system. And this is what I come to. This just came out. This is right from the United Nations website. Code Red for Humanity. The Secretary General calls the latest International Panel on Climate Change report Code Red. Alarm bells deafening, choking our planet. This is if this isn't a wake-up call when the mainstream United Nations is saying this to us, and the building industry contributes an incredible amount to this problem, both in our building, our operating, and then the short lifespan, especially in North America, of houses. So what we want to do here is we have a worldwide, and on top of that, we have a worldwide housing crisis. We believe everyone deserves a home. And we realized that we couldn't solve a problem in the housing by doing one house at a time. And at the same time, because of COVID and all this, we have masses of people leaving the cities. The baby boomers are wanting to downsize and get back to a simpler life. The millennials, the same thing, two big things. So we must change our concepts. We don't want 30-year houses, we want multi-generational houses. We have to build with local materials as much as possible. We have to eliminate petrochemical products. We have to heat and cool with renewable methods, and we must economize to make housing affordable for all, so that the whole building system has to be affordable and not what we're seeing in Canada now, in places like Vancouver. So what are we funding there? So we have to have a big mental shift. And that's why just since May, since we finished our last project, we want to leverage that into what we're calling carbon neutral communities. And that's what we're going to be striving for. Again, most people want to do the right thing. All of the environmental, social, and business motives, we all want to do the right thing, but we don't have a way to do it. So we think that a Hempcrete community would reduce the cost to provide attainable housing. It will reduce environmental impacts. It will reduce greenhouse gases. So to us, this is a really no-brainer way to take a strong step in the right direction. This is some of our business plan covers this, but I'll just explain a few of them, or you can read through. But basically, we're looking at 40 to 200 homes for our first community, and we're thinking of a lot of them that we would like to allow other developers and people and community groups to start to plan and build and give the technology to allow this to happen. So we want to go past green builds, go for smaller house size, depending expandable, but smaller to start with and expandable, pedestrian oriented, and geothermal plants. We have designs for community based energy and heat and hot water projects as well. So that there's all sorts of things, and having common house. So we have a very holistic design, and it's not a suburb type development. And we want to be able to take these all over the world is our goal. We have 7 immediate opportunities, 2 in the United States, 4 in small town BC, and then a couple on the Eastern Seaboard, which are very exciting. So we've actually been running behind the ball since May to just catch up with all this. It's like everybody here, I think you get this, but it's really exciting to see that the mainstream and the investors and the government are starting to sit up and pay attention. And so we have transportable modular homes. There's prefabricated hemp panels. There's a lot of talk about Hempcrete 3D printing. These are all things that when you have volume building, when you're building a village, and Chris and Gabriel will know this, that it's a lot of work to build one house. And we're all going towards the Hempcrete panels and working towards ways or blocks or different ways to make it easier. When we get into volume, large volume, everything changes, and that's what we're anticipating. So just to sum up, we're really focused on everybody needs a home. We want to create carbon neutral homes and move towards that as much as we can. With every house that's built should be a little bit better. And working with the communities to create the volume, we need to find more ways to sequester CO2 and use less energy, and have houses that last multi-generational rather than decades. It's not acceptable what we're doing. And it's really exciting that that people like Chris and Gabriel are actually promoting and have the opportunity to set this up and to make it happen. So, this is kind of reflects again on our mission statement. We believe that all humanity deserves net zero, safe, sustainable hempcrete houses. And we believe passionately the power of communities to foster evolution and the relationship between us and our environment. We have to get back to a place where we're living with our neighbors, we're living in the environment, and we can actually make a change. So that's the big vision, and that's all I have to say. That's my story, and I'm sticking to it. Thank you very much.
Thanks so much, Jason. What an inspirational story! Great to hear about your journey and all the things along the way. I'm wondering, we've got a couple of questions from the audience, but I'm also wondering what were some of the bigger roadblocks and obstacles for you when you kind of did that first home? Was it sort of belief in the community? Was it getting the materials together? Was it sort of getting through some mental blocks on your own part? What are some of the struggles that you had right off the bat?
I could write a book just on that. The lack of materials, actually the lack of materials made us innovate a lot. One of the disappointing things was we went to our municipality, and and this is one thing that kind of speaks to the way things are, but the municipality wanted to support us but had no resources to. And the mayor did say, well, we'll get out of your way, but we can't help, we have no resources to help you out. So there was no provincial or federal funding that we could find to do it at the time. The biggest thing on the ground level though, was not knowing how to build. And our first 1,200 square foot house took, I think it was 11 weeks of a big crew and buckets and wheelbarrows and hoisting wet hemp and lime over our heads into the wall. Whereas when we did our second house, which was 2,500 square feet, it took half the time for more than twice the size. So one of the biggest challenges was figuring out how to do it. And a lot of our consulting, we help people out and to help them figure that out so they don't go through the torture that we went through on our first house. But I think anybody could figure it out if they got some basic building skills, but it was really the building processes of a mass wall construction and how to work with the hemp that was the biggest challenge, really.
No, for sure. A lot of trial and error there, right? And it's great to have folks that have kind of gone through that, like yourself and Gabriel and Chris, and can kind of give that knowledge, right? And when Gabriel was saying he had 75 folks that he was teaching, you know, it's really all about passing that knowledge on, right? And getting people to you know, just keep that momentum going. So this may be a bit of a repeat, but Lori's wondering, curious what you mean by hemp houses sequestering CO2. I know Chris talked a little bit about that, but that was just a question that came up from Lori.
Oh, Chris is answering here.
There we go. And Chris, feel free to come on in.
Sure, yeah, I'll talk it through too. But you know, essentially with plant material, hemp or any other plant material, though those plants are pulling CO2 out of the atmosphere when they grow, so they're actively drawing carbon down. But typically, you know, the any of that fiber that's not used goes back to the atmosphere very quickly. It either gets burned off, it gets rotted off, but that CO2 is returned to the atmosphere, which is sort of how the planet has worked. You know, there's a CO2 cycle from the atmosphere to plants back to the atmosphere. But if we can take a bunch of plant material that was destined to have released its carbon back to the atmosphere and put it in buildings for decades or a century or more, that's CO2 that was in the atmosphere that's now no longer in the atmosphere. And so we can actually achieve a fair bit of really meaningful carbon storage that way. I know right now the sort of amount of hemp being grown isn't vast, but if we look at the amount of grain straw being grown on the planet, we grow 4 billion tons of grain straw a year, and all that carbon goes back to the atmosphere. But while it was growing, that pulls the emissions of the country of India out of the atmosphere. So, you know, we already have these plants, farmers are already growing things that draw down these, you know, vast quantities of carbon, and then we just sort of put it back in the atmosphere. So this kind of construction, whether it's hemp, straw, cork, you know, sometimes wood, you know, you're sort of preventing that carbon from returning to the atmosphere, and instead putting it away in a building. And I put a link to a good paper that's a good, easy to read sort of intro to that notion in there.
Yeah, no, that's great. We did a session on mass timber as well last year, so I'll put a link into chat. Jason, you had some thoughts on that?
Yeah, I just want to say that as well. Thanks, Chris. That's really well put. The other thing is we have to compare it to the actual carbon and embodied carbon cost of vinyl siding from overseas. So it's also a comparative analysis as opposed to an absolute that we're talking about. So that's, to me, that's an important factor.
Yeah, no, for sure. And we have a few other questions, and we can open up these questions to the whole panel as well. So feel free to jump in here, everybody. Edward is wondering, for the same population density, which is better, a high-rise building or individual homes? That could be a bit of a longer argument.
I'm not sure how much high-rise buildings are. Density is typically, some kind of density is typically more energy friendly, but there's a lot of metrics that could be in there that could tip it back the other way at some point. And then there's the quality of life and as well. So I think I think there'd be a tipping point myself. I don't, Chris or Gabriel, do you have an idea?
I know that there's a lot of debate. There's been a series of really interesting academic papers over the last couple of years, looking to see what is an ideal density from a carbon footprint point of view, and the leaning. I mean, there's arguments on all sides, but there's a lot that says like cities like Paris, like Edinburgh, that are quite dense, but dense in like a 6 stories and less kind of way, are quite likely the best case scenario. But it's a pretty hard thing to just sort of generalize on. But there definitely is a building height at which it's very hard to make the building low carbon and to operate at low carbon, because just the amount of energy it takes to pump water up 80 stories, to run elevators up 80 stories, to the amount of material you need to make the frames and the foundations that hold that up. There is a tipping point, but it's argued sort of like where, how many stories, does it start being unsustainable? But there definitely is a point where it does get that way, but it's a hard thing to put a number to.
Yeah, absolutely. No, those are some great thoughts. Daniel's wondering, have you considered pursuing an environmental product declaration, what's called an EPD for the product? Does anybody have any thoughts on that?
The U.S. Hemp Building Association has a committee working on that right now. The tricky thing with an EPD is that it has to be quite specific to a material. And so, if Gabrielle is using hemp from here and lime from there, and Jason's using hemp from here and lime from there, and I'm using some other hemp and lime, none of those are going, like, each of those would need its own EPD for the EPD to have any validity. So, it serves, EPDs are great. I mean, it's what I do base all my carbon research on, but they're very product specific. And so they work well for a company that, has a giant factory and makes rock wool, because they get their raw materials from the same place. They use the same process, so they can sort of say, this is the carbon footprint of our rock wool. But, for some sort of more custom material like Hempcrete, every single person making it wouldn't need to do that. And it's about a $25,000-$30,000 process to make an EPD. So you have to be producing in enough quantity for that to be worthwhile. But I think what you'll see is companies like, Just Biofiber or other places that are producing a block where they can quantify those things. You'll start to see EPDs. I know that the Hemp Insulation Company in Quebec, their EPD literally came out a couple weeks ago. So it is starting to happen, but it's definitely more sort of manufacturer related than artisanal, makers of material related.
Yeah, no, that's great. Good points for sure. So I want to talk a little bit, Jason touched on it a bit, but I want to talk a bit about 3D printing and see what experience everybody has on that. Have you guys kind of had some experience with 3D printing? Do we think that that's a bit of a game changer in terms of being able to scale the technology? Anybody have some thoughts? I know Michael has a bit of a specific question, but I just wanted to open it up first, just with some thoughts about, is 3D printing going to be a bit of a game changer there?
Oh my gosh. Couple of my executive team members are all excited about 3D printing. I think it's got a long ways to go. I think it's a great idea. It's again, everybody was excited by blocks when they first started making the first Hempcrete structural blocks. Every building method has its own pluses and minuses. And so I think I haven't seen anybody who's ready to start 3D printing hempcrete yet. But that's not to say it couldn't happen and couldn't be viable and couldn't be transportable to different areas. Building is a complex process, and I think we like the idea of 3D printing because it simplifies it. But I don't think we'll see it soon personally. But Chris or Gabriel, do you have ideas?
Yeah, Chris or Gabriel, any thoughts on 3D printing?
Yeah, maybe in 5 years, something like that.
Sure. I know they're doing some stuff with straw now that's pretty interesting. So potentially hemp is the next to come there. So Michael's wondering, what kind of mixes are used in 3D printed hemp houses? Does the mix have additives more than just the lime that makes it more structural than typical blocks or panels?
I don't know of anybody who's doing it, and I haven't read anything in detail about doing it. So I'm not sure it is being done. If it's being done, I'm not quite sure how. So it's outside of my experience for sure.
Yeah. Okay. Well, we'll wait to see where that goes with the technology. Gabriel, did you have some thoughts there?
Yeah, I figured, and also our lime binder is a lime base. We have some additive for catalyzer in the or lime binder. So I figured then to have a 3D printer, we're gonna have a special mix. Depend how this work, but of course it can just not happen with the basic line.
Great. Christine is wondering, is it possible to print with hemp in concrete for the hopper-fed extrusion printers, but it wouldn't be Hempcrete per se? I have done small-scale extrusion with short hemp fibers.
Yeah, the problem when you use concrete for the binder is not you less many of property of the lime. The hempcrete is not breathable the same, and it's not dry the same. It's not the same insulation. So it's why we prefer to have a wood frame for the structural and do it light hempcrete for the insulation. Yeah. So we have tests to do, a lot of R&D to do for that. Yeah.
There you go. Well, that's exciting. It's still developing.
Mm.
So if folks want to jump on and sort of ask questions directly, this is a great time. Just to throw your name into chat, or best yet to raise your hand with the reactions at the bottom, and I will unmute you so you can ask your question directly. We have a bit of time to kind of go around to the panelists. I have a couple questions too, but if anybody does have any follow-ups, wants to jump in and chat about the work they're doing around Hempcrete, this is a great time. Just raise your hand there with a reaction and I'll unmute you. I wanted to chat a little bit about, building Hempcrete in different areas and different regions. We talked a little bit about Ontario, Quebec, BC. Is it easier right now to build a Hempcrete house in BC due to their building codes? Or is it sort of, depending on where you are, is it easier in Quebec or Ontario? Regionally, is it difficult in some areas versus others? If folks want to build, depending on where they are, what do they have to kind of keep in mind there?
Get an engineer. We have to have engineers on board. You want to spend a lot of time, and this is one of my big things that I really go through with people, is that you want to spend a lot of time in the planning and preparation, and have an engineer on board who understands what you're doing, preferably an engineer, structural and building envelope engineer who's used to working with Hempcrete already, or else you'll have to pay to educate them. That's another thing. You could spend $5,000 just educating your engineer. So, if you can avoid that, all the better. And the planning and preparation, and some things like Metro Vancouver, I saw somebody asked if it's available in Metro Vancouver area. Potentially, yes. That's close to where I live, but I know the city of Vancouver has made it very difficult to build green buildings because they've raised they've created some standards that that don't recognize the values of a hempcrete wall, for example. And so they've made it actually more difficult for people wanting to go outside the box and build with hempcrete or cob or straw bale or things like that. So yes, it can be your engineers, you get out of jail card, and then proper planning. And I would say the last thing that I'll say on this is, do not try to educate your building department. Go in there with all your engineered plans and slap them down on the table and leave. Do not try to educate your building department. That never works out well.
That's it. Yeah. Here in Quebec, it's more easy to get the permit. We don't need all the time engineer standard, but often in Ontario, we have engineer on board for that. I have engineer for structural and all that, but not for the envelope. With many municipality or town, I'm okay to they recognize how the Hempcrete is working. That's it.
That's great. And around that, Pamela is wondering, is an alternative compliance package required to use Hempcrete for all provinces across Canada? Not sure if you guys are aware of that or know that alternative compliance package or have experience with that. Okay, well, I know Chris had to jump off, so.
Oh, Chris jumped off? Okay, I was going to wait for Chris to jump in on that. And I have another phone in my house ringing, so hopefully it's not too loud for people.
Oh yeah, no worries.
Yeah. So I don't know about the other provinces. Every municipality in British Columbia has its own building code. So they have the provincial building code, but every municipality like Vancouver has set up a very, very strict, much more rigid than the provincial code. So again, I would just go to your engineer on a case-by-case basis and work around it with your engineer stamp.
That's smart, yeah. And Michael's just wondering if you can provide links to any publicly available studies with NRC around Hempcrete. So that might be a good one for Jason if he can dig anything up or share a contact there. I want to talk. Yeah. So Jason, that's great. Did you have some thoughts on that?
Go ahead. I'm going to just shut this phone off. Sorry. Go ahead and finish your thought.
Yeah, no worries. I wanted to chat a little bit about, design and maybe, because we haven't talked too much about architecture. I know Gabriel in his presentation really showed, some of the different things that you can do with Hempcrete as far as the archways and things like that. So are we thinking that Hempcrete is going to really change the way we design our homes? And is it going to kind of free things up as far as, not necessarily having to live in sort of boxes and being able to shape things a little bit more? Are we starting to think that Hempcrete is going to be able to, our architecture's coming on board and architects coming on board and getting excited about this, and talk a little bit about the design elements and how those might be freed up with Hempcrete.
Yeah, but I will show you. You have a lot of possibility of design with the Hempcrete. And often when an architect is comfortable with the technical things for the hemp wall, and they could challenge you, but you have to challenge with the handicraftsman or the builder to be. So I'm really now I'm really implicated. I'm work on the design with I have a crew of an architect, an engineer, and we do the design to build with hemp, and sometime with to go to the budget too, to have it. We know how to build. If we do this choice, it's going to cost more, and if we do on this way, we could have a better deal for a better price for the same result. Yeah, so. The design is important technically, but after the creative possibility is really large. Yeah.
Yeah, no, that's great to see. Jason, any thoughts on sort of design, architecture, how that maybe change with the oncoming of Hempcrete?
Um, I think anything is really possible. If you look at if you look up online, Italy, for example, did the first Hempcrete apartment building in the world. And if you look up Italian Hempcrete apartment building, then you can see some really, it's really impressive and totally not my style. Like, I don't know if I'd live in it, but it's very, very impressive. Gabriel's getting to the arches and everything, but I think you said, Gabriel, that the arches are very labor intensive.
Yeah,
that beautiful arch ceiling, right?
Yeah, it's a for specials project with
right.
good budget.
With a good budget, yeah. So
of course,
yeah. So really, and then if we on the West Coast here, we use a lot of timber frame. I think as we move towards a panelized system, and if somebody sets up a factory, which we may end up doing in BC, you may be able to more quickly handle curves and things like that. But I think, again, if you think of typically that you have to make some kind of form to hold whatever you're making, so it's always easier to do straight. Curved is more problematic. So I think anything is doable, but I don't think that unless you're using the biofiber blocks, which are very difficult to play with because you've got a square block that's hard to do anything with. I think for regular construction, it's pretty much up to your design and your budget. I think it comes down to those two things, and anything is doable for sure.
But just some things are possible for around the window, or shape the Hempcrete after it's square. You could shape it and form it with the lime coating. So this does not have the same impact on the budget. Yeah, so it's not we can do the big curved walls and all that. We can do, but it's take more time and all that.
Yeah, no, it's great to see some of those photos of stuff that you've done. Jason, did you have a couple of thoughts on that?
I just had, go ahead. I was just trying to quickly pull up a picture because I think of the roundhouse we did in Nelson. We did a handmade fireplace surround, and I was just going to try to pull that up for you, but for your guests, but I'll see if we can in time.
Sure. Yeah. I know John's got a question here. So John, you should be able to unmute yourself now and come on in with your question.
Okay, cool. Nick, Chris, Jason, Gabriel, thank you for such an awesome presentation. Very, very informative, very exciting, very interesting. I had a number of questions which I unloaded onto Chris on the chat, but something that I would like to ask Jason in regards to 3D printing, which is a crazy idea. What is the substrate that allows you to 3D print if not the item or the product is already grown? You know, what is it that you're printing?
I think that's why somebody mentioned that it would in the chat there that it wouldn't really be Hempcrete anymore. So really, and that I know we call it Hempcrete, like concrete, so you think concrete. But really, the Hempcrete is a non-structural wall infill. The way we do our Hempcrete, it actually is structural to a degree. It will hold up windows, it will stabilize the house. But as far as the engineers in the building department and the actual function of it, as you start to make it more structural, technically you could make your foundation out of Hempcrete, but you would have to add a lot of cement and other aggregates and glues to it to make it strong enough to support your house. So if you're wanting a non-structural wall infill, then you have to, 3D printing is going to change everything about that. And maybe even if you're 3D printing around a structure, a metal or wooden structure, you're still going to have to deal with the effects on the breathability, the moisture. But like just for example, with the NRC, we tested two of our plasters with the NRC, and because the hempcrete wall breathes, you want the moisture or the vapor going into the wall almost at the same rate it's coming out. And some plasters, even the European plasters, will have a less than a 1-to-1 ratio. So the moisture will go in and come out at 75% of the speed it went in. And so that will retard. So you want the walls to breathe and get wet and to work, as opposed to regular construction. So the minute you start changing any element of that, you're into a whole other set of testing and unknowns. Our first round with the NRC, we were just tasting the baseline of all our hempcrete and our plasters to make sure that it matched the European tests. So when you're dealing with something that works and you want to change one little bit of it, how is it going to affect the performance on all these other aspects, the R value and the thermal inertia, all of those things. So it's a really exciting thing, the whole 3D printing.
Jason, I don't know if I'm confused myself about
Sure.
the 3D printing technology,
Okay.
but 3D printing, as I know it, in respect to kind of resin, kind of layers of stuff, something has to be kind of excreted out in a kind of a thing, and so the material has to be on site, and then it's follows like a CNC kind of pattern. But so I was wondering really whether the technology was around specific details, or was it in total, so that you had, I don't know, some kind of hemp lime mix on site in a big vat, and then you literally printed your house.
That's how I would see it. Yeah, you'd have to mix it. You'd still have to mix it and print it. And we don't know. And I think that's what I was trying to get at, was that we don't know what happens to the hempcrete when it comes out and out of the extrusion. So that's to me, that's the key thing, and how it affects all the dozens of aspects of the hempcrete that we've been working with.
Thank you.
Yeah, and I just shared, not necessarily on Hempcrete, but I just shared an interesting article that I read a few weeks back in Wired around some of the stuff they're doing for straw. So that might be interesting just in chat there for everybody who's interested in kind of 3D printing. Pretty neat to see what they're doing there. I kind of want to sort of start to wrap things up. As a final question, I want to know from Gabriel and Jason, what do we need to do to see more Hempcrete homes popping up around Canada? Do we need to change the building codes? Do we need to pressure the politicians? Do we need to, just take it in our own hands and start building our cottages ourselves? Do we need to invest in communities? What are some thoughts around what we need to do to see this technology and this building material grow in Canada?
Yes.
All of the above.
Yeah. I think it's funny. I'll jump in and then pass it over to Gabriel. But when back in the 2010 or whenever, we had the Conservative government in power, and we'd be at conferences. Sorry if people are conservative here. Actually, I'm conservative, but we'd go to these conferences on hemp, industrial hemp, and the government bureaucrats would come, and I got to know a lot of them, and they'd apologize to us every time. Sorry, there's no money for you guys. The bureaucrats got what we were doing, and all the government workers, but there was no political will to take on industrial hemp at the time. And then we got the Liberals in, and they legalized marijuana and left the industrial hemp in the dust. So there is a very big element of political will that needs to happen. And so I think, again, our approach has just been, let's go out and start building, and let's start building a house, and let's start building a village. And I think if we can address the housing crisis, or tie it into the carbon issue or the housing issue, I think that Hempcrete would have a lot more legs. And the last thing we need lobbying money. And if you want to get something done, you need lobbyists in Ottawa.
Yeah, good points. Good points. Gabriel, did you have a few thoughts on that? And obviously, you're doing a lot of grassroots things there in Quebec.
Yeah, I know a lot of people. They are building house, and when technically the Hempcrete is not the way, then they are able to. I propose go ahead with hemp wool. So a lot of we could build a lot of home with hemp wool at a good price, and so yeah, we have to mix the techniques, and just build with biosource material. That's the way. But about the government and all that, of course, if we could go on carbon, here we have the carbon. Call it carbon credit or
The carbon tax.
yeah. I think if it's many way could, but it's more for larger hemp industry, and this could be organized to take a big volume, and yeah, we need to go at the next step with 1 billion of investment in hemp industry, and there
Absolutely. No, it would be great to see.
it's going to be another game. Yeah.
No doubt. Well, hopefully this helps move the dial and introduce it to more people. I want to kind of end things off with some final thoughts and just what's coming up for you guys. So, some final thoughts and what you're excited about, maybe some future projects that you're looking at. Why don't we start with Gabriel, and then we'll go over to Jayeson for some final thoughts and what projects you have coming up.
Yeah, okay, but yes, it was about my final talk to say let's invest and let's do hemp home many way is possible. So start to dream about that, and after build it.
Yeah, great words for sure. Jayeson, some final thoughts and maybe what you have coming down the pike. I know you're looking at communities out there. Any other projects that you're getting excited about?
Yeah, we've got a couple projects on a couple universities that we're in discussions with now for houses for visiting professors. So, getting it out there in a way that people can experience it and live in it. I think like Chris said, you get into a Hempcrete house and you go, oh my gosh, it's so soundproof. I feel so safe in here. And so we're thinking of doing a little Hempcrete shed bed and breakfast on our own place near Vancouver. But really, really what we've spent the last 3 or 4 months on is getting the villages going. And I'd like to tell everybody here that, think of where you'd like to live and where you'd like to build a carbon neutral village. And then let's make some nice villages all over the world. And so that's really what we're working on right now.
No, that's a great thing to work towards, and want to congratulate you both for the amazing work that you're doing. And yeah, if you do get an Airbnb going out there, I'll be one of the first to visit and come stay in it for sure. So I know folks are probably jumping over to the debate next, and hopefully maybe there'll be some questions about building materials and carbon neutral things over in the debate. So I want to thank everybody so much for their engagement here. It's been a great session. I want to thank Chris. Unfortunately, had to jump off a little bit early, but I want to thank Chris. I want to thank Gabriel. I want to thank Jayeson so much for an amazing session. I invite everybody to join us for our next one, October 14th. We'll be talking again about some great organizations. And anybody in the Ottawa area is invited to join us on October 2nd for our sustainability showcase as well. So once again, a huge thank you to our presenters. Thanks to everybody for joining us for Green Drinks. And let's keep fighting the good fight and keep building our homes out of these revolutionary materials, and keep pioneering those new technologies so that people can understand what's possible. Thanks again, Gabriel and Jayeson.
Thank you, guys.
Bye-bye.
Good night, everybody.
Good night.